Okay, students, we have to learn the third level of partial fractions. If you look at this first question, this is the first level of the or the first kind of the partial fractions. Now, why do we call this first kind? Because this had the linear factors. All of them, they were linear factors. So that is the first category over here. Okay, this question number one. In your second question, there were whole squares, like you had x plus 2 whole square, and then 2x plus 1 into x plus 1 whole square. So there you learned that, like for example, if you look at this b part, so you started by saying that this is going to be a over 2x plus 1, then b over x plus 1, and then plus c over x plus 1 whole square. So this square thing was converted into two different denominators, okay? Now, if you look at the third case, this was the second one, okay? If you look at the third level over here, in this level, you see that as in the second case, this 2x plus 1 whole square, this is a quadratic expression, but there was a whole square. But if you look at this x square plus 1, this is also quadratic, but you cannot further factorize it. You can't factorize this into any two linear expressions or factors, okay? This x square plus 5 is a quadratic factor. This 2x square plus 1 is a quadratic expression, okay? And similarly, this 2x square plus 5 is also quadratic. So I'll be combining these 2 and 3 together today, and I'll be telling you, if you remember yesterday, I told you that this could also be written as a over 2x plus 1, and then plus bx plus c over x plus 1 whole square. Because the rule is that the numerator that you suppose that has to have a lower degree than the denominator. So if you don't want to write maximum number of fractions, then you can also take it as just x plus 1 whole square, okay? So maybe towards the end of this lesson, I'll ask you to split this one of these in both of these methods, and then you will have to show that they are both the same, okay? But first of all, let's move on to the question number 3 and see how to convert these given fractions into their partial fractions, okay? So for that, I need to have some space here. I'll be on to this question number 3. Okay, so the rule is when you have such a fraction whose denominator is quadratic and cannot be further factorized, and how to do that. Okay, so I'll be starting from 3a. So we have 2x squared. We have 2x squared minus 3x plus 2 over, I have x into x squared plus 1. Now, one thing is for sure that you always have to make sure that if this given fraction, if it is a proper algebraic fraction or an improper algebraic fraction. So this is a proper fraction because the numerator's degree is 2 and the denominator's degree is 3. Okay, so how many fractions we shall have for this given single fraction here? Yes? Any idea how many fractions we can have?
2.
2, because there are two factors down here. So one will be a over x, and this time you will have to write the second fraction as bx plus c over x squared plus 1. There is no other way of writing this x squared plus 1. This cannot be further factorized. Just for the sake of your notes, though you don't have such questions in your syllabus, but suppose if this was blah 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 over x into, and this was x cubed plus 1, supposedly, okay, then this would be a over x, and Guess what would be the numerator for this x cube plus 1? Yes, that will be bx square plus cx plus d. Because your denominator is cubic, so the numerator has to be quadratic. But luckily, we don't have such questions in our syllabus where these factors, they go up to the cube, okay? We have the questions up to this x square only. Okay, so now this 2x square minus 3x plus 2, and that will be, now I can skip that step where we were showing the process of taking LCM. We know that the denominators are going to be cancelled, so we are just going to write the numerators. So this is how you have a will have x square plus 1 with this, and bx plus c will have x with this, okay? So what should I put first of all x as? Put x equal to what? Yes?
0.
0, okay. So you put this x equal to 0, and there you go. All of this is 0, just 2 is left here on the left hand side. And here you have a into 1, so that is your a. And all of this will become 0 because your x is 0 here. Okay, so here is your a, which is going to be 2. Now, how would you find the values of b and c? Hmm?
Put x equals to -1.
Okay, now this time I would rather be saying that going for comparison, I'll be comparing the coefficients of x squared first, because if I put anything, I'll be having uh, at least 2 variables with me. So now I see that this a into x will give me a ax squared, and then this bx into x will give me bx squared. So I have already got the value of a, so I can find this value of b easily if I compare the coefficients of x squared. So this 2 is equal to a plus b. So when you put your a as 2 over here, your b will be 0. Now you can put x, like maybe 1, okay? So you can put x equal to 1. So you have 2 minus 3 plus 2 from here. And this is a is 2, 2 into 2. B is already 0, so we're left with C over here and C into 1. So you have 1 here, you have 4 plus C here, so C is -3. Got it? So finally, this,
Sir,
this beta,
sir, can we do this through simultaneous equations?
you can do with any method, beta. What you do it the way you want. But I'm telling the simplest way. You see that when I compare the coefficients of x squared, I knew that I'm going to get a and b. And since I had this a already with me, so that is going to be a better way to get this value of b. If you just had put your x1, then you could have got all the a, b, and c in your equation. Okay, so
Okay,
you
sir.
have to find out the ways to save your time and to get to your solution as accurately and as quickly as possible. Okay, so this is now going to be this fraction is going to be, this is 2x squared minus 3x plus 2 over this x into x squared plus 1 is same as 2 over x and minus 3 over x squared plus 1. Okay, if you want to take a screenshot, do that quickly, because I'll be moving to one more part, maybe part D, and then you can practice this yourself. So I'm going to move on to this part D now. Okay, part D. In this part D, we have minus 6x squared minus 21x plus 50 whole over 3x minus 5 into 2x squared plus 5. Okay, so how many fractions then, guys? No one wants to respond.
plus bx plus
There are
c.
two fractions because denominator cannot be written as a product of more than two factors. This is already fully factorized and a proper algebraic fraction. So this is what you have. One fraction will have just a constant in the numerator because the denominator is linear. The second fraction will have the linear numerator because the denominator is quadratic one. Okay. Now be aware of this minus over here. So I'll keep this with the numerator. So this is minus, I'll be multiplying all of them with a minus. So minus 6x squared plus 21x minus 50, that is equal to a into 2x squared plus 5, and then this is bx plus c into 3x minus 5. Okay, so let's start finding these values of a, b, and c. So I will, first of all, I am really clear that I should be going for this. I'll put x as 5 over 3. Okay. Are you all with me or you're sleeping right now? Yes, Bacho. How many of you are sleeping? All of you are sleeping?
No, sir.
Mhm. Okay, so I'll not be putting it here because this 3x minus 5 will be 0 right now. Now, please tell me quickly, what do we get after all this simplification? This is going to be uh, 3 twos are,
90 minus 95 over 3.
this is minus 95 over 3,
3.
and that is going to be 25,
95 over 9.
95 over 9. Thank you, beta, over 9. I believe this looks to be okay. So this A is going to be equal to minus 3. That is your A. Okay, and then we, what should I do now? I should be obviously comparing the coefficients of x squared, because here I have x squared and I have the value of a, and here I have x squared. I can get to the value of b this way. So this minus 6, that is equal to 2a and plus 3b. So we have a as minus 6. Oh, once again this b is 0. Oh, this is just a coincidence. In the previous question, this b was 0, and now this is 0 as well. Okay. Now let us compare the coefficients of x. Though we can put any value like 0, 1, or minus 1 here, but I want you people to get used to it, comparing the coefficients of x. Now, when I compare the coefficients of x here, you see that I will not be having any term with the coefficient in terms of a. Okay, from here, this left hand side, I have 21, and you see this bx into this minus 5 will give me minus 5bx. So I'll be writing minus 5b, and this c into 3 will give me 3cx. So this is 3c. So this way, this c is going to be equal to 7. Okay, and this is going to be minus 3 over 3x minus 5, and then plus 7 over 2x squared plus 5. Now this is your turn to try the parts B and C. So in this E part, we have, I'll draw a line here, okay? I'll do it with two methods. Quickly, I have just 6 minutes with me. And you should also help me, you should have your calculators with you, okay? To support me, x minus 2 whole square. Okay, I'll write it with the, here I want to write the maximum number of fractions, okay? So I'll do it like this. So this is going to be 3 equal to a into x minus 2 whole square plus b into x plus 2 into x minus 2 and c into x plus 2. So we start by, we say put x equal to minus 2. Please keep an eye over here so that if I make a mistake, you must catch me, okay? Now, if I put this x as minus 2, I'll be getting the value of this a. Minus 2 minus 2 is minus 4. 4 square is going to be 16. So this is 16a. So your a is going to be 3 over 16. I'll put x equal to 2 now. Okay. So I'll be getting the C. So this 3 is equal to 4C and C is 3 over 4. I'll put X equal to 0 and the values of A and C. This is 3. A is 3 over 16 into 4. B is into minus 4 and C is 3 over 4 into 2. Okay, quickly tell me, this is going to be 3 over 4 and plus 6 over 4 minus 4b. This is 9 over 4. So 4b is 9 over 4 minus 3. This is 12 and this is 9 minus 12 is minus 3. So your b is minus 3 over 16. Okay? So I have this here. This is going to be 3 over 16 into x plus 2. That is how you write this. And your b is, this is minus 3 over 16 into x minus 2. And this c is 3 over 4 into x minus 2 whole square. Now let's do this quickly through the second method where we just keep two fractions, okay? So this will be a over x plus 2 and simply be x plus c over x minus 2 whole square. When you have to write this, like you want to write the minimum number of fractions, so you will apply that third stage method, okay? So this 3 is going to be a into x minus 2 whole square, and then you have bx plus c into x plus 2. I'll start by putting x equal to 2. No, x equal to minus 2. When I put x equal to minus 2, so I have this a. You will be surprised to see that this a is going to be same. So minus 2 minus 2 is minus 4, square is 16. So this is 16a. So your a is 3 over 16. So you see that both the a's are same. Okay. Now I'll be putting x equal to 0. When I put x equal to 0, this b will be eliminated because this is bx. We always do that. Bx, b into x, b into 0 is 0. Okay. So this is going to be 3. A is 3 over 16. And here we have 4. And we are left with c from here and 2 from here. That is plus 2c. Now, c and b will be different because they are just in one fraction here. So this is 4 4s are. So this 2c is 3 minus 3 over 4. This is 9 over 4. So your c is going to be 9 over 8. Okay, now let's quickly find the b. So I can compare the coefficients of x squared. comparing the coefficients of x square. So there's no x square on the left hand side, so 0. Here I have a x square, so this is a, and I have here plus b. So your b is minus a, which is going to be minus 3 over 16. Now, how can we claim that they are both the same? So A is same, so that means this is going to be same. So we just have to show that this thing is going to be same as this, okay? Now, if I put the values of B and C into this over here, so this will be, you see that this will be B is, your B is, um, come on, yaar, why are you disturbing? Okay, B is minus 3 over 16. So I will be writing it as, let me make some space here. Okay. I'm running short of time, just 1 minute left. Oh, so this B x plus I'm really afraid this will have to go into the next video over x minus 2 whole square is going to be b is minus 3 over 16x. This is 9 over 8. If you quickly take the LCM, the LCM is 16, so this will be minus 3x plus 18 over 16 into x minus